Where cell is there, I replace with a 0 volt. Then what all that internal resistance that will get, that only will be retained 4 ohm, and this is 2 ohm. And this was that wire, no, which was there. And this is the terminals. And now what you should do, you have to find out the effective resistance RAB. Let's check how these 2 ohm and 4 ohm they are. First, simplify from here. These two are parallel, no, because they're connected just by a wire. These two are parallel. So this will be 8 by 4 by 3 ohm. And again, the effective will become in parallel with this 4 ohm. I'll simplify the circuit. AB. So this you do one thing, call point P. This is some, I'm going to retain it. Now this will remain as it is, 2 ohm, 4 ohm, and this is 2 ohm. First I'm replacing these two. How these two are? These two are 2 4 by 3 ohm. So here 4 by 3. Where the point P? Now the point P will come here. So this is 4 by 3 ohm. And where is that wire? The wire should come from this wire. I'll put a red color. So let's retain throughout the problem. There's nothing but connected to point P, no? Now that wire should continue, no? So it will be it is here. Because it is also connected to the other resistance. I think I'm bringing the total circuit. Okay, now see this. This particular red color wire will extend till here, no? So I'll extend it. Okay, let it be. Now 4 by 3, 4 ohm. So let's draw one more circuit. Let's draw one more circuit. So this is the point A. This is the point B. This is the value of R which is needed. So this is, now you may ask it like this, tricky problems like this. So you have to be a little bit careful. So this was the point P, and let that wire, let me bring it like this. Okay, now 4 ohm and 4 by 3 ohm. Effective resistance of this. Anybody value?
1.
How much?
1.
1. Okay, this will be 1 ohm. And next come for this, we wanted RAB, no? So there's nothing but one wire is there, no? So shall I now make A and P are at same potential? Because they're connected by a wire. So now A comma P, you write like this. A comma P, you call this is some point C. A comma P, this is B, and let this be C. Now between A and B, there's a resistor R. Like this. Between A and C, there's a 2 ohm. Between P and C, there's a 2 ohm. Between B and C, there's no resistance. But between B and P, there's a 1 ohm resistance in there. Between B and P, one ohm resistance is there. Okay, let's see that one now. So what I should do, I should remove that resistor, and what is the effective resistance as seen by that. That's what the method, no? Like previous problem. So what all that resistor R is there, we have to remove it. What is the effective resistance as seen by R? Okay, now what I should do here, I'll remove that resistor because that was our method, no? I'll retain all. That was the thing, no? Because if I remove in the beginning, you'll get confused. Therefore, now I removed it. So it is the thing. Now come for that. What is the effective resistance as measured between terminals RAB? Only 1 ohm, no? 1 ohm. So therefore, what will happen to this particular A comma PC, that one? So that will not come into picture here. So here RAB should be equal to only 1 ohm. So what I should do now here, the effective resistance R should be equal to RAB. The way we simplify circuit, it depends on that one. So like this, a tricky number of different types of questions can be asked here. What is the method? What is the method? What is the method I told you? The resistor across which power dissipated is maximum. There's a resistor across which the power dissipated is maximum. What is the maximum power dissipated across the resistor R? So that, and what should be the value of R so that the maximum power will be dissipated across it? That was the question. There should be maximum power should be dissipated across that resistor R. And what should be the value of R is asking. So then what I should do here now? I should find out the effective resistance. I should find out what happened. I should replace the across terminals AB. First, I'll remove the resistor R. Then across AB, what is the effective resistance seen by this circuit? What is the effective resistance seen by this circuit? So to find out that effective resistance, what I should do, where all cell is there, I should make EMF 0. If any internal resistance, retain. 2 ohm is internal resistance, so I'll retain 2 ohm. Then I'll simplify circuit, I'll find out for RAB. You see this. Because if I remove RAB in the beginning, you'll get confused. So therefore, I just made circuit here. Now I'll find out the AB. So what happened to the cell? The EMF has become 0. The internal resistance will get added up to circuit. And what happens to that capital R, sir, where it is? What is the effective resistance as seen by capital R? You assume that you are as if you are capital R. Then you see the total resistance of circuit. So what is the total resistance as measured across AB? So finally what happened? We get answer equal to 1 ohm. So what should be the value of R to get maximum power? 1 ohm is telling. No, sir, we didn't get this idea. We are finding very difficult to acquire this logical thinking. What is the alternative method? Find expression for current I through the resistor R. Find current through this. Calculate power. Then that R is unknown. So what all you get expression for current I will be in terms of capital R. Calculate power. Then dP by dR equal to 0. So just imagine, can you really solve the problem by that method? How many loops are there? 1, 2, 3, 4. Easily what happens? You have to write so many equations. Then again you have to differentiate. Again you have to equate 0. Instead what happens? They're giving us this alternative method. So hereafterwards, any complicated circuit, let it come. You want to find out effective resistance. So if any cell is there, replace with that internal resistance and replace that resistance across which where you are finding out that one. Where the value of R you are finding out, replace that resistor. Any resistor is there. Find out effective resistance across the terminals. Then substitute that RAB. So our entire circuit was like this. Means even this is A, this is B, no? This was the resistor R. So what we did is RAB we have found out, and this is VAB. If you want, you can calculate VAB also. you have to connect the cell, and with that you should calculate the drop across A and B. That will be VAB, and there's a value of R. So see now, when the power dissipated will be maximum, when the power dissipated, when the load resistance becomes equal to internal resistance of a cell,